Hey guys, welcome back. This video is going to be an instructional video on how to assemble and do the wiring for the Gumball everything machine. For those who are just tuning in, I've been working on a project that sort of hard to explain. I guess it would be a universal power supply. It's a machine that I hope with the help of 3D printing, you'll be able to convert it into any machine just by 3D printing a few parts. The idea is that with a 3D printer and this machine, you'll be able to build almost anything. So far, it can convert into a drill press, a lathe, a flat lap, a split lap. It could function as a micromotor or a flex shaft, a tumbler. I mean, the list really just goes on forever because the goal really is for this machine to be able to do everything. I've been procrastinating putting out this video because, well, for a few reasons. One, because I've been having so much fun making new accessories and add-ons for it, I needed a functional machine to do that, so I didn't want to have to take the machine apart. And the second reason is that I've been kind of trying to work out the best way to film a tutorial on the wiring. The wiring is a little hard to get on video, so I'm going to do the best I can with some diagrams and whatnot. I have a lot of new conversions that are done that I'm going to release right after this video, but a lot of you guys are done with your 3D printing and you're anxious to get the assembly video, so I figured I'd get that out of the way. I have a scroll saw conversion that's ready, I have a cabbing machine conversion that's ready, and I have a whole bunch of accessories that are really cool. That'll be coming in the video right after this one. Alright, so let's just jump into it, I guess. Alright, so we're going to start with this hole on the back. This is where the DIN plug is going to go. But I noticed that depending on where the DIN plug comes from, they vary in size by like a fraction of a millimeter. So your DIN plug might not fit in this hole. The hole might be a little bit undersized for your DIN plug. In that case, all you need to do is just take a drill or some sandpaper or whatever, just enlarge this hole by literally a fraction of a millimeter to where this is going to fit in there nice and snug. Okay, so that's going to be your first step. Next thing you're going to need is a power cable for the machine. Any old power cord will work. Ideally, you want a round power cord. This is an old power supply for a computer, but really any cord should work. But ideally, it's going to fit in this hole here. So you're going to want it to be round ideally and something that can fit in this hole. We're going to seal this with hot glue when we're done, so it doesn't have to fit perfectly, but just something round, something that fits in there, that should work fine. You're also going to need a little bit of extra wire. I find that a thinner gauge wire is better. Something like this. This I'm using from an old charger cable. I'm just splitting it down the middle, and I'm using segments of this for the additional wire that we're going to need. Again, any wire will work, but I find that thicker wire like this, it becomes problematic because at the end you're going to have to stuff all your extra wiring in there, and just having a thinner wire that you can make longer so it's just easier to, you know, organize all your parts and stuff while you're doing the wiring. It's just much easier than with thicker, heavier cable. If you use thicker or heavier cable, you're going to have a hard time stuffing it all back in there when you're done. Alright, so the first step, we're going to attach the speed controller. You can see exactly where the speed controller goes. There's an indentation here, so it's going to fit in here like this, and then we're going to screw the bolt on in the front. So let's do that, and then we'll move on. So this gets pushed in through the back, this nut gets screwed on here, and then after the nut gets tightened, then the knob goes on and it gets tightened with the screw on the side here. So let me get that put together and then we'll crack on. Okay, so this is screwed on, that part is done. So now you're going to see that the speed controller has 3 wires, a black, a red, and a yellow. This is really simple. On the power supply, you are going to see red, green, and black. That's where you're going to put those 3 wires in the corresponding colors. So it's going to go black here, yellow here, and then red here. We actually don't have to connect these yet. They might get in the way. I usually connect those at the end. So, but just know that's where they're gonna go at the end. All right, so the next thing we're gonna do is the forward and reverse switch. By the way, before we go to that, I just wanted to mention that you'll see an on and an off here with these two corresponding points. They have a wire connecting those two. I'm not sure if your power supply came with that or not. I don't even remember if I did that or if it came like that. But if it didn't come like that, you need to bridge those two, the on and the off. Just bridge those. All right, so your forward and reverse switch should have come like this. Some of them have the connectors with these that are already wired, but most of them are coming like this, not wired yet. If they came with the connectors, I suggest you remove them. And the reason why is because the connectors come with these thick wires, and it's a little tricky to get it all stuffed in there with the wires that come with it. So if you take them off, we're going to rewire this using thinner wire, so it's just more manageable. So this is going to go in your top printed part right here. It should pop in there nice and snug. And then on the back, we're going to have 6 connection points. These need to be wired like this. They're going to go, you're going to take a small segment of wire like this that you scavenged from a charger cable, or if you happen to have some extra wire or whatever, you're going to connect. This is where it's going to start to get tricky and hard to do it with filming, but let me do my best. Let me zoom in. So to wire this, you're going to want to take a tiny segment of wire, and you're going to want to bridge this point here to this point here, and then you want to bridge this point here to this point here. So you're going to make an X with the wires. Let's do that, and then I'll show you what to do next. All right, so this is what it's going to look like when you're done wiring it. It's going to be like an X pattern. You can definitely solder these if you want. I strongly suggest you do. But just a heads up that I'm going to be doing this entire build with no soldering. I just am approaching this from the assumption that most of you guys don't have soldering capability or have knowledge, or I'm just going to do this in a way that anyone can do it. But if you have soldering capability, you definitely are going to want to solder these. At the end, we're going to put some hot glue on there because I'm not going to solder these, just for the sake of showing you that this can be done without soldering. You just want to make sure that there's no shorts here. None of these wires can be touching each other. They just have to be that X pattern. Then the next thing we're going to do is we're going to cut a segment of wire, I don't know, let's say 6 inches, and we're going to run one from here and then a separate one from here. All right, let's do that, and then I'll show you what to do next. All right. When that's done, it's going to look like this. You're going to want to have about 6 inches of extra wire on both sides. You can cut it shorter, but it's better to have more than not enough. And then the last thing you're going to do is you're going to take another 2 sections of wire, and you're going to run them 1 6-inch lead off of this end and 1 6-inch lead off of this end. Again, soldering or using these types of clamps are definitely better, but this can be done totally without soldering, and I'm going to put this one together with no soldering just to show you guys. We're going to just make sure that nothing is shorted here. None of these are touching, and then when we're done wiring, we're going to just put a little bit of hot glue over each connection to keep it in place and keep anything else from touching it. So yeah, so just one more wire here and one more wire here. About 6 inches of lead will be fine. So let's do that, and then we'll move on. All right, when you're done, this is what it's going to look like. We're going to have that X. We're going to have one wire coming off this lead, one wire coming off this lead, and then one wire coming off this lead, and one wire coming off of this lead. All right. So we're done with the forward and reverse switch for now. We can put this aside. All right, so the next is going to be the DIN plug. The DIN plug has 3 prongs. So you will see a tab on the top and then 3 holes. This is how it goes in, with the tab on the top. And then from the back, if we turn it upside down, you are going to see, let me try to get a better camera angle. So this is the face with the tab on top, and then from the back it's going to have one big tab here and then 3 small tabs. For wiring, we're only concerned about this tab here on the right and the tab on the left. We don't care about the top or the bottom tab. Now again, if you have soldering capability, you're going to want to solder everything. But with these, soldering is a little tricky because it's very easy to melt this plastic here. So what I found is that if you just connect your wires and then just put some hot glue on them, you're fine. You're better off soldering everything with this machine if you have a soldering iron, but even if you have a soldering iron, you run the risk of destroying this, because if you get it just a little bit too hot, the plastic will melt. So you want to connect a piece of wire with about 6 inches from here, and then another lead you want to go off of this prong with about 6 inches of wire. So let's do that, and then I'll show you what to do next. Okay, so we got these 2 wires connected to those 2 prongs. You want to get these really tight, so wrap them around like as many times as possible, twist it so they're really tight. Make sure there's no shorts, and then we're going to just put a dab of hot glue on here to cover them. If you have little crimped wire connectors or a really precise soldering method, that's obviously the way to go, but this will work just fine. All right, let's before we put the hot glue on this, let's just move that over to the side for a minute, and then we're going to move on to the power supply cable. Your power supply should have 3 wires in it: a positive, a negative, and a ground. Every wire is going to be different, but for most of the ones that I found, the red is always positive, the blue is going to be negative, and the gray is going to be your ground. So those are going to get wired right here where it says input. So the red is going to go on positive, the blue is going to go on negative, and the gray is going to go on ground. So let's get that wired up, and then we'll move on. All right, next we're going to wire is this switch here. It's very easy to see where that goes because, again, you have it modeled into the case. So it's going to go in this hole here with the button on the top. Let's get that in, and I'll show you how to wire it. You're going to put it in through the hole, put this washer on there, and then this gets screwed on nice and tight. And when it's done, this is what it's going to look like from the front, and like this from the back with your 2 wires at the bottom. All right. Now we're pretty much done. Now we can just attach all the wiring. What I find it's the easiest way for me to do it is I lay the power supply on top of here, and then I wire everything up using the least amount of wire possible, and then I fit the power supply in, and then I stuff all the extra wire in right here. So let me wire everything up, and then I'm going to, there's a few more connections that aren't as clear as what I explained. I'm going to have to draw those out on paper though. I'm not going to be able to show it on video. So at this point you would connect all the obvious connections that I already explained, and then there's going to be some unconnected wires, and I'll show you what to do with those. Alright, so at this point all my parts are in, and my forward and reverse switch is wired. I covered it in hot glue. You shouldn't do this yet. again, I can't stress it enough. If your kit came with connectors or if you have soldering capability, that's the right way to do this. I'm just going to do it the ghetto way just to show you that it's possible if you don't have all these things. The goal of this project is to be as cheap and easy as possible. So I'm just doing it the cheapest and easiest way possible just to show you guys. So everything's connected and I've covered all my connections with hot glue, but I don't think you should do that yet. Don't cover your connections with hot glue yet. I think at this point you should wire everything up and test it. I've built this thing several times, so I'm confident it's going to work, but if you're doing it for the first time, you probably want to wire everything just to make sure everything functions. So let's do that, and then we'll close it up. You're going to take your motor bracket. There's an indentation on one side. That's the side where the wire goes. So you're going to insert the motor with the wire going into that indentation, just like that. And you want to have it set up. The accessories are going to work where, if you see it goes from black to silver here, you want to push the head up just so that the silver is showing. So all the black from the motor is hidden behind the spindle motor mount. All right, and this is how you want to bolt it to your top plate. Okay, so I started wiring this. I did the red, yellow, and black from the speed controller, like I showed you in the beginning of the video. Next, we're going to connect the power cord. We're going to run the power cord through the hole, and then we're going to connect it to your input, your positive, your negative, and your ground. I showed you earlier, your cord might be different, but it should be positive, should be red, negative should be blue, and your ground, I should say could, not should. All the power cables aren't the same, but on mine it's red is positive, blue is negative, and gray is ground. But yours might be different. You'd have to check it. But they go on your input. So let's get those connected. Okay, we got the positive, negative, and the ground connected from the power cable. And now we're gonna hook up the spindle motor. That goes through the final remaining hole that's open here. That's where the spindle power cable is gonna go in. You might want to, depending on how much extra cable your spindle motor came with, you might want to add a little bit of extra length on here. It's just easier to manage it while you're wiring everything and keeping everything separate, to test it to make sure everything's good before you permanently attach everything. So I find if you add a little bit of length to the positive and the negative, it makes it a little bit more manageable. So we're gonna stick the spindle motor through that hole, and then we're gonna do the final wiring. All right, so for the remaining wiring, this is where it's gonna start to get tricky to show you on film. So I'm gonna draw it out with a diagram because it gets too tight in here for me to do it while I'm filming. So you are going to have the positive, I have a diagram here. Here's your spindle motor. You're gonna have your positive red wire from your spindle motor. You are going to, and then here is your kill switch. This is, you're viewing this from the back of the kill switch. So you're gonna take the right wire, the bottom right wire viewed from the back of the kill switch, and you're gonna connect it to the positive red wire on your spindle motor. And then you can close this circuit, tape it off. You can't have any exposed wires here. So you're going to connect those two, and that's done. Next, you're going to take your forward and reverse switch. This is going to be your orientation, and it's going to have one wire coming out from the middle right and one wire coming out from the middle left. Those two wires, the right wire, the one coming out from the right, you're going to plug into, let me show you. On your power supply, there will be an output. You already plugged your power cord into the input. Now you have a positive and negative for your output. The right side wire of your forward and reverse switch, when you're viewing it from this angle, will get connected to your positive, and the left side wire from the middle will go to your negative. All right, I got this all wired up. I couldn't show everything on camera because it was too difficult to film while I was doing it. But I did make a diagram on my computer, so when I'm done, I'll go over the remaining connections through a diagram so it'll be clear. But right now, it's all wired up. You want to test everything to make sure all your connections are correct and everything works before you tape up all your connections. All your connections need to be covered so that you don't have any shorts. You can cover it with electric tape, or like I did in the case of here, I used hot glue, but you could, like I said, soldering or crimp connectors are definitely suggested, but I just wanted to do this the cheapest, easiest way possible just to show you guys that it's possible. All right, so the first thing you want to do is plug it in, and you'll see a little red light on the power supply that shows that it's getting power, so that's good. One thing that's important before you plug it in, you want to make sure that this knob is all the way counterclockwise, because you turn the spindle on by turning this knob clockwise. So you want to make sure that it's all the way off before you plug it in, otherwise your spindle motor could possibly be running at full speed and it'll go flying off the table. That's a big problem. Also, your forward and reverse switch, you want to make sure it's in the middle, not forward, not reverse, in the middle before you plug it in. Okay? So at this point we plugged it in. The power supply is all the way to the left or counterclockwise, and now we're going to start testing it to make sure everything works. So the first thing we're going to do is push the switch in the forward position, and then make sure that the spindle motor is clear so it can spin clearly without hitting anything. And then we're just going to give it a little bit of power. Okay, we see the spindle motor works. That's good. Now let's test the kill switch. That's this switch under here. That should kill power to the spindle motor. And you turn this up and nothing happens. So the kill switch works. Now let's see if the reverse works. So now we'll do the other direction. Well, let's see if we have spinning in the opposite direction. Yeah. So the spindle motor works in both directions. That's good. Now we need to test the DIN plug. So let's plug that in, see if that works. All right, so I'm going to plug in the DIN plug, and we're going to test it. All right, that worked. So that shows that the spindle motor and the micro motor work at the same time. So let's kill the kill switch, and now only the micro motor should work. Okay, good. Now let's try it in the opposite direction. Yeah, so that works. So at this point, everything's good. We can put it together now. By the way, the first thing you're going to do, you know what? Let's do that now. Hold on, let me show you. We're going to drill these two holes here for permanently attaching the DIN plug. We're going to use the micro motor to do that. So let's do that now. All right, so I drilled two little holes here. I'm going to use these little wood screws, these tiny little wood screws that I had, but you could use any hardware you want just to put a screw in each one of those holes. And then we're pretty much done. We just need to assemble this. You're going to unplug the machine, and at this point, now all of your open connections, you want to cover them with tape or proper crimped connectors or whatever you have on hand to finish this properly. There can't be any exposed wires. You're going to pull all the extra wire out. You're going to shorten any wires that you might have to shorten if your wires are too long. Then you're just going to stuff everything back in there. And what you're going to use to connect, I can't do it right now because I actually lost the screws. They fell behind the table, so I had to get more. But you're going to use, for attaching the spindle motor to the top plate, you're going to use M5 screws, 6 of them. I like using these black hex screws. If you get 60 millimeter M5 by 60 millimeter, 6 of them, they should work out so just a little bit of the screw protrudes out of the bottom here, where you can just put a nut on there. If you use screws longer than 60 millimeters, you're gonna have to cut some of it off, because otherwise it's gonna hit the power supply when you put the top on. So you're gonna put those 6 bolts on with nuts on the back. And if they're the right length, there should be very little extra screw sticking out of the back, and the top should go on easily. And then you're going to use just 4 M5 screws. You could use 20 millimeters is fine. These holes are set up so you don't need to do any threading. The M5 screws should screw right into the plastic. And those are M5 by 20 millimeter. And then you just don't tighten them too much or you'll strip the plastic. But if you use M5, you shouldn't have to even thread it. They should just be able to be self-tapping, sort of. And then you attach those 4 screws, and you're done. If you guys have any questions, let me know. I'm going to now show you the diagram. I drew a diagram on my computer screen to kind of give you a better idea for the final wiring. If you guys want to print it out, maybe that'll help you. Anyway, if you have any questions, let me know, and let's go to the computer. Okay, so here's the diagram. If you were following the video, you should have everything wired up except 3 points. I have the 3 points that you need to connect marked in green. This first green point here, this is only 2 connections. It's your positive motor lead going to the right bottom wire on your kill switch. You connect those 2, and that connection is done. By the way, all of these components, I have them being viewed from the back. So if you know, to determine right or left, it's if you're viewing it from the back. All right, so this connection is done. You can tape this one off and close that connection. The next one is going to be this one right here. This one is 3 wires connecting. It is your negative motor, your left top forward and reverse, and then it is your right tab viewed from the back on your DIN plug. You connect those 3 wires here, and you can close it off. When you see this purple wire cross over the black wire here, that's not a connection, all right? The only connections are marked with dots. If a wire crosses over, that's not a connection. And then your final one is this one right here. This is also going to be 3 wires connected. It's the left DIN plug connected to the top right wire on the forward and reverse. And then finally, that gets connected to the left wire on the kill switch. And you're done. That should finish the wiring. And you should be good to go. Test everything, make sure it works. If it works, you could seal off all your wires and close everything up. I'm sure there's going to be it's the internet, so there's obviously going to be some people mentioning should have done this or could have done this. Yeah, I mean, a few people mentioned it. There should be a fan inside. Yeah, there's a lot of things you can do. The point is that it's a $65 machine, all right? I personally don't think you need a fan. I do think it should be soldered. If you have soldering capability, you should solder it. But it's just like a cheap, dirty, get it done kind of machine, you know? Obviously, yeah, it could be made better, but it would be a lot more expensive. So, the only last thing I want to mention is the micromotor. I have it wired so the micromotor and the spindle motor are sharing a power supply. So that means that you cannot run the micromotor at full power. The spindle motor, yeah, you can run the spindle motor at full power, but when you're using the speed controller for the micromotor, you don't want to run it over, I don't know, say 20 or 25%. If you have experience running a micromotor, you know what to listen for. You know when it's getting too much power. And I would say if you run it over 20 or 25%, you could risk burning out the motor. You sort of have to be an idiot to let that happen because you can clearly hear when the micromotor is being given too much power. But I just want to mention that. So yeah, the spindle motor, you can run at full power, but the micromotor, be careful with it. Listen for when it's running too hot, and then bring it down a little bit. And other than that, that should cover everything. If you have any questions, let me know. Otherwise, stay tuned for the next video. I have a scroll saw conversion that's done, cabbing machine conversion, and I'm working on a ring saw conversion that I'm pretty excited about. All right, guys, thanks for watching. Thanks for supporting the project, and I will see you in the next video.